All right, we're going to look at vertical and horizontal asymptotes here, and a little bit of your domain. So we have the graph here of x plus 3 and x over x plus 2 that looks like this. And so what you notice is going up and down right here, you have a part where it tapers off on both sides. And what happens is we have this vertical asymptote because where the denominator is 0, it's you're not allowed to have a denominator of 0. It makes it a non-real number. So since we can't have a denominator that equals 0, that point is going to be an asymptote. So when it asks what would make that denominator equal to 0, that would of course be a negative 2. So when we think about the domain, it's going to be x is really all real numbers except for negative 2. And so we'll just write it as x is not equal to negative 2, meaning that it could be anything else except for that one point right there. Then when we're looking for what are the vertical asymptotes, it's just going to be x equals that negative 2. And so that's going to carry all throughout. And we're looking here for vertical asymptotes is anywhere you have a vertical line going through, it's going to be your asymptote. And you can also have more than one. So if I've got a point there and there, you're actually going to have two. And we notice that's at negative 2, positive 3. So this matches up with that middle graph. And we could match up the other ones pretty easily, just looking at where the asymptotes would be. Then we have here looking for the domain and the vertical asymptote. Again, all we're doing is saying, well, what makes that equal to 0? So for this one, same, it would not be equal to negative 2 because that'd make it equal to 0. Vertical asymptote is x equals negative 2. And you have a couple here where we'd have to factor this out using, this one would be difference of squares. So x plus 2, x minus 2. And the way that we'd write that, domain x is not equal to 2 and negative 2. Vertical asymptote would be x is equal to 2 and negative 2. Okay, the rest is just factoring. That carries on the same throughout. Then you have in 7.2 our horizontal asymptotes. And so now we're not looking at, we talked about this vertical line for this one. You also have this horizontal line here that cuts it apart. At this one would be y equals 1. And so there are a couple of rules for this. So you have this nx over dx. And assuming that like it's as simplified as possible, there's no common factors, then at most it's going to have 1. So it's either going to have 1 or 0. And so if the top one is greater than the bottom one, then it's going to be the line y equals 0 as far as the degree.
Teacher, please hold your students in your hallway.
So if you had, say, x squared over x plus 2, then, or no, I'm doing that the wrong way around. So if I have x plus 2 over x squared, meaning n of x is less than d of x, then that's going to have that y equals 0 asymptote. Then for my next one, if they are equal to one another, so that would be our x plus 3 over x plus 2, then it's the line of a over b, where a is the coefficient, the number in front of the highest powered variable. And on the top, b is the one for the bottom. And so since there's just a 1 in front of both of these, your horizontal asymptote would be at y equals 1. And then on this one, if I had x squared over x, if it's a greater degree, then I could say x plus 2. That way they don't cancel out. If it's bigger on the top, then there's no horizontal asymptote there. So let's look at a couple of them as examples. So for this one, first horizontal asymptote, this one has a greater degree on top. So that's going to be no horizontal asymptote. These are the same. So my a over b is going to be 2 over 1. So y equals 2. And then this one is greater on the bottom. So that one's going to be y equals 0 according to our rule. Then here, looks like greater on the bottom, we do y equals 0 again. So the rest of these go through doing all three parts, but that gives you the basics of how to find those horizontal asymptotes, how to find the domain, and those vertical as well.